In this video, we will discuss pH, acids, and bases, and how they're measured. As you watch and listen, take notes. Write down questions that you have and review any slides that are confusing to you. Post your questions to the class blog. The pH scale is a chemical property which measures the acidity or alkalinity of an aqueous solution. The pH scale measures acidity or alkalinity. Alkalinity is also called base. We'll use base and alkalinity interchangeably. Base and alkalinity is determined by the number of free hydronium or hydrogen ions. pH is the potential of hydrogen ions, or sometimes referred to as the power of hydrogen. For your morning work, define potential and then use your definition to explain why pH would describe the potential of hydrogen. Be prepared to defend your response. The acidity or alkalinity of an aqueous solution is measured by the pH scale. Note that acids are below 7 and that bases are above 7 on the scale. Let's talk more about acids and bases. When an acid is poured into water, it dissociates and gives up hydrogen to the water. In this example, HCl dissociates in water to become chlorine and hydrogen. The chlorine has gained an electron to become more stable and carries the negative charge. The hydrogen has donated its electron, making it positively charged. When a base is poured into water, it dissociates and gives up OH hydroxide to the water. In this example, the sodium hydroxide dissociates to sodium hydroxide in water. The solution in the beaker is basic because it contains free hydroxide ions. The pH of the solution will fall somewhere above 7 on the pH scale. Solutions that are basic will have a pH above 7. Strong base solutions will have a pH closer to 14, and weaker base solutions will have a pH closer to 7. Acids release hydrogen ions into solution. Some common characteristics of acids include pH of 0 to 6.99 or anything below 7, and they taste sour. They're corrosive to metals and turn litmus paper red. Strong acids can eat away stone, buildings, and statues. Here are some examples of common acids and their pH value. Remember, the pH value is equal to the concentration of the solution. For example, hydrochloric acid, which has a pH of 0, means the concentration of hydronium ions of the solution of hydrochloric acid are equal to the molar concentration. Bases release hydroxide ions to solution. Common characteristics of bases are a pH of 7.01 or anything over 7 to 14. They taste bitter, have a slippery feeling, and turn litmus paper blue. Strong bases are corrosive to flesh and eat away skin. Some common bases include cleaning products and ocean water. Tums are alkaline and an antacid. They neutralize the acid in your stomach. We'll talk a little bit more about neutralization later. The pH scale 0 to 14 is the full set of pH numbers which indicate the concentration of hydrogen and hydroxide ions in water. Anything less than 7 is considered acidic. Anything greater than 7 is considered a weak base. The pH scale is logarithmic. Logarithms of numbers that are multiples of 10 are merely the exponents of the number including the sign. The definition of pH is the negative logarithm of the hydrogen ion activity in a given solution. For instance, each whole pH value below 7 is 10 times more acidic than the next higher value. Example of pH 4 is 10 times more acidic than pH 5 and 100 times, or 10 times 10, more acidic than pH 6. For your morning work, find the pH of an acid that has a molar concentration of 0.0004. Be prepared to defend your answer. If there are exactly the same number of hydrogen and hydroxide ions in the solution, there will be no leftover hydrogen ions or hydroxide ions. When there are no excess hydrogen ions or hydroxide ions, the solution is said to be neutral. This generalized chemical equation is called a neutralization reaction. Any acid plus any base produces a salt plus water. The term salt simply means an ionically bonded chemical combination of a metal and a nonmetal. There are lots of salts. This one in the example just happens to be common table salt, NaCl. On the pH scale, a pH of 7 is neutral. A neutral solution contains equal numbers of hydrogen and hydroxide ions. If hydrogen and hydroxide ions are added to the same solution, they'll combine chemically to produce water. If there are exactly the same number of hydrogen and hydroxide ions in the solution, there will be no leftover hydrogen or hydroxide ions. When there are no excess hydrogen ions or hydroxide ions, the solution is neutral. Remember that Tums we talked about before? The Tums is a base, and when it's added to the acid in your stomach, it neutralizes the acid, making you feel better. For your morning work, John has a glass of orange juice. Which solution will best help him neutralize its pH? A. Milk, B. Rainwater, C. Bleach, or D. Sulfuric acid? Be prepared to explain your answer.